Hello, dear students. How is it, everybody? I hope you all are doing well. So, students, today we are starting this chapter Carbon and its Compound. So, this is our lecture number first, and let's begin this class without wasting our time. Okay, dear students, so we will start with importance of carbon. We all know that there are lots of metals and non-metals, or you can also say there are lots of elements in a periodic table. But why are we only discussing this carbon? Why this is important for us? So the first reason for this, that carbon is found in living organism. It is found in living organism, and this is also found in our food, and it is also found in plastic like polyvinyl chloride, like polyethylene. So that's why lots of the compounds around us consist carbon. So that is the reason that carbon becomes so important. The other point is, it is also a very important part of our fuel, like natural gases and like petroleum. So that's why this becomes very important. I hope, guys, this point is clear to you. Now, after understanding this, let's talk about some other things related to the carbon. So carbon is tetravalent. Carbon is tetravalent. Now guys, why it is tetravalent? Because this carbon has 4 electrons in its valence shell. So what is the atomic number of carbon? The atomic number of carbon is 6. So if you write the electronic configuration for carbon, then it will be 2 and 4. And you can see that in the last shell of carbon there is 4 electrons. So that's why it is tetravalent. Now guys, one thing you need to remember, that this carbon cannot transfer this 4 electron. So if it is not able to transfer its 4 electron, then it will not be able to form ionic compound. It can also share its electron, or you can say it can only share its electron and form compound. Now, what is the reason that it can only share its electrons? So guys, there are two reasons. The first reason is that electron transfer is a energy expansion process. You need to expend your energy to transfer electron. But guys, carbon is a small atom. So because it is a small atom, so it is very difficult to lose 4 electrons, because it will require lots of energy, and for a small atom like carbon it is not possible. So that's why it cannot lose its electron. Now the second reason, why can't it accept 4 electrons? So guys, we all know that to complete its octet, it needs 4 electrons. But let's suppose this carbon has 6 protons. Because the atomic number of carbon is 6, it means it has 6 protons and 6 electrons. So if you are taking 4 extra electrons here, so it is not possible for these 6 protons to hold those 4 extra electrons, because you all know that why electrons are rotating around this proton, because this proton is applying a force over it, so it is holding these electrons. So but if 4 more electrons will come here, then it is very difficult for 6 protons to hold 10 electrons. So that's why it cannot accept extra electrons or 4 electrons. So that is the reason, guys, carbon is unable to form ionic compound, or it is unable to transfer electrons. So guys, it can only share electrons. So that's why carbon is tetracovalent. Tetracovalent because it can only form covalent compound. Covalent compound. I hope, guys, this point is clear to you. Now, if it is clear to you, so let's move ahead on the next slide and let's talk about the uniqueness of carbon.
Okay, dear students, so we are on this slide now. Here we will be talking about the uniqueness in carbon. Okay, so why carbon is unique? What makes carbon different from the other atoms? So the first point here is that it can form large number of compounds. It can form large number of compounds. So basically, if you count the number of carbonic compounds, so it will be higher than the number of compounds which are non-carbon. Okay, you can say non-carbonic compound. It means it doesn't have carbon atom. So basically, we can say that this is the reason of uniqueness in carbon, that it can form large number of compounds. And now I am also telling you the logic behind it. So basically, guys, what happened, that carbon is tetravalent. Carbon is what? It is tetravalent. Now why it is tetravalent? Because it has the valency of 4. Okay, it means it has 4 electrons in his outermost shell. So that's why it can share up to 4 electrons. That's why it is tetravalent. And basically, one more thing, that why it can only share electron, why cannot it transfer electron or accept or lose its electron? What is the reason behind it? So basically, guys, what happens, if it accepts 4 electron, so it will be difficult for its nucleus to hold those 4 electrons. Okay, because 4 electrons, if it comes in its atom, so it will be difficult for its nucleus to hold it. Now, what if it loses 4 electron? So for losing electron, it requires some energy, and for losing 4 electron, it will require high amount of energy. So that's why it cannot lose electrons. It cannot lose 4 electrons, because if it wants to become stable, so it either need 4 electron to accept, or it either, you can say, or it loses 4 electrons. So that's why it can only share electrons. So you can say that carbon, it can only share electrons. I hope guys this point is clear. Now one more property of carbon that makes it unique from others, and that is catenation. So basically what is this catenation? It's very easy. That carbon makes long chains like this. Okay, carbon makes long chains. So that's why this property of making long chains is known as catenation. So I hope this point is clear to you. Now one more thing I want to let you know, and that is polymerization. Polymerization. So basically what is this polymerization? It is also a very, you can say, unique property of carbon. So basically what is polymerization? It is the process to create polymers. Okay, it is the process to create polymers. So in this process what happens? The smaller molecules, which we call monomer, they are combined to create larger molecules. Okay, let's suppose, let me give you an example of this. So I am explaining you this. So basically let's suppose this is what we call ethene. Okay, and when this molecules combines, okay, with other ethenes, so it will form polyethene. It will form what? It will form polyethene like this. So basically n number of ethene molecules are combined to form this. So you can say this will continue. So this property is known as polymerization, in which smaller molecules combine to form a bigger molecule. I hope this point is clear to you. So let us move on to the next slide, and here we will be talking about isomerism. So basically guys, to make you understand what is isomers, let us take an example of butane. So first of all, we will make the carbon skeleton. So in butane what happens? There are 4 carbon present like this. Okay, now this can also be shown like this. Okay, now guys, what will happen if I fill the remaining valencies with hydrogen? Let's suppose I am filling the remaining valencies with hydrogen like this, like this. Okay, now also I will be filling the remaining valencies here also. Basically 4 valencies should be filled. Okay, I hope guys this point is clear to you. So now what we see here, we see that both these structures have the same formula. Okay, like let me tell you that what are the number of carbon on this structure? 1 2 3 4, 4 carbons. Okay, and what are the number of hydrogen here? 1 2 3 4 5 6 7 8 9 10. Okay, so basically the number of hydrogen here is 10. Now if you count the number of carbon and hydrogen for this structure, so the number of carbon is 4 and the number of hydrogen 1 2 3 4 5 6. Basically this is also hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here also 10 hydrogen is present. So as you can see that both the structures have same molecular formula. Okay, it means it has same formula. Okay, so but their structures are different. So that's why these are known as structural isomers. These are known as what? Structural isomers. So what is this structural isomer? Where the molecular formula, or you can say the formula, is same or it is identical but different structure. It means it has different structures but the formula is same. So that's why it is what? Structural isomers. I hope this point is clear to you. So if you are asked what are the structural isomers, so what will you answer? You will answer that the structural isomers are with identical molecular formula but different structures. So I hope guys this thing is clear to you. So let us move on to the next slide.
So here guys, we will talk about some of the examples. So the first question here, why carbon cannot accept electrons? So guys, the answer is, we all know that if carbon electron or if carbon accept 4 electron, then it will be difficult for 6 protons to hold 10 electrons, because carbon already has 6 electrons. If 4 electrons comes, then it will become 10 electrons, and it is not easier for 6 protons to hold 10 electrons. So that is the reason that carbon cannot accept electrons. Now guys, the second question is, what is the atomic number of carbon? So we all know that atomic number of carbon is 6. Okay, because it comes on 6th position in periodic table. So I hope guys these examples are clear to you. So now I am ending this lecture, and thank you so much guys. We will meet in the upcoming lectures. Till then, thank you so much and bye bye.